Hello, welcome back. So this lesson today is going to start talking about measures of center and measures of variation in data. This is where we really start jumping into like the nitty-gritty of statistics. There's an important thing that you need to make sure, an important resource you need to make sure that you have in order to be successful in this section. And I would highly recommend that you get a graphing calculator. Now, you seniors are probably laughing at me like, I ain't going to buy no calculator now. There's only a week of school left. But if you're college bound, right, which the majority of you probably are, this is not the last time you're going to see stats. You're going to see them again in college for sure. Statistics, basic elementary statistics are a part of any undergrad curriculum. So it's good that you get a feel for it right now and sort of an idea of how to manipulate the calculator to do a lot of this heavy lifting for you. If you don't use the calculator, then what you're going to end up with is you're going to end up with a lot of time sunk into filling in formulas to solve problems. The other thing too is I am going to show you a tool that you can do online for free that will get you through this topic here. But I want you to think, just think ahead, because yes, this tool will help you today online. But the biggest thing is, like, if you're in college and you're taking a test or something, you're not going to have access to this website. Even if you go and take a test, like if you're taking an online class and you take it at the testing center or whatever, those browsers are locked down. They're only going to let you access like Blackboard or whatever. At least that's, just one example. But you probably won't be able to get into this free stat calculator website. So, but you probably will be able to bring your graphing calculator, and this thing does all the stats heavy lifting for you. Well, most of it. So let's go ahead and get started. We're going to go ahead and start filling in these notes. The first thing we're talking about is measures of center. This says measures of central tendency. That just means how likely is it that the data drifts towards the center? What is the center of this data? What's the middle? And there's a couple different ways that we can talk about what the middle is. A measure of central tendency is a value that describes the center or the middle of a data set. Ran out of room, sorry. The first one that you're probably most used to seeing is going to be the mean. And the mean is the average of the data values. And there's a Greek symbol that we use called mu that stands for the average or the mean, and it looks like this. And so you're going to start seeing this symbol and lots of other symbols going forward. And so just make sure that you really have this down. So when you see this mu symbol, you think that it means the mean or the average, okay? You can also have the median, that is the middle. That's the middle value. And then you also have the mode, and that's the most frequent value, so the one that appears the most. And basically, after we calculate the mode right here, we're pretty much never going to see it again, so that's cool. But mode really doesn't tell us anything about the data except what value appears the most. So let's do some calculations. We need to find the mean, median, and mode for this data set right here that we're given. And so to find the mean, you need to add all the values and then divide them by how many values there are. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9 values. N is 9. That's another variable that we use commonly in stats, which is the N. That is the number of pieces of data that you have in your data set, okay? So if we add all these up and then we divide by 9, I'm not going to write all that out. I don't expect you to either. I'm going to do it all right on my calculator. Let's just pull that up. The first value is 58 plus 53 plus 59 plus 51 plus 46. I can't type apparently. 46, 35, 51, 58, and 60. And then you divide them all by 9. And that gives you the average, which is the mean, which is mu. Oops, it's not writing because I have my calculator here. The mean, which is mu, is 52.3. We're just going to, leave that rounded that way. Okay, the median. So basically for the median, you need to have your data in order. You need to have that ordered first. So it's from smallest to greatest. So the smallest value is 35. And then the next one up is 46. And then do we have a 50? No, we have 51 twice. Spoiler alert, I think I found the mode. Okay, so 51, 51, 53 is next. And then we have 58, 58 again, and then 59, and then 60. Okay, so that takes care of all those. And then I'm going to switch pen colors here so you can watch how we do this. To find the middle value, you start shaving off the numbers on both ends equally. So one off this side, one off this side, then one off this side, then one off this side. So 35, I don't know why there's suddenly a bunch of boxes on here. That's pretty cool. I don't know why that's happening. Okay, so 35, 60, 46, 59, 51, 58, 51, 58, 53 is the median. It's the value in the middle. Now you might be wondering, and I think number 2 has this, what if you cross all those values off and you get to the middle and there's 2 numbers left? There's not one exact value in the middle, there's 2 that are next to each other. Well, all you do is just average those 2 together and that's your median, okay? So the very last thing we have is the mode, and there's actually 2 modes for this data set, because if I look at my data, and I'll use green for this, if I look at my data, 51 showed up twice and 58 showed up twice. Because they've showed up the same amount of times and 2 is the highest frequency, both of those values are the mode. Okay, I want you to apply what we just did and solve number 2 as a classwork problem. I want you to tell me the mean, median, and mode. And if you would like to pause your video now, you can give it a shot while we're here on this wavelength. I will pause mine as well, and then when we come back, we're going to move on to the next section. Okay, next topic in these notes is going to be about measures of variation. And what a measure of variation is, let me switch my pen color. It's a measurement, a value that tells you how spread apart the data is in the data set. So we'll put that in here. A value that describes how far apart the data is in a data set. And so you might also see this referred to as dispersion. The way you can remember that is like, let's say that you have like, I don't know, some muffins in your hand. This is like such a stupid example, but let's say you have like some muffins or cupcakes or something, and you just want to like yeet those all across the room at all your friends, So you can say that you had all of them here and you dispersed them and now they are spread out. And now you're only going to think of me doing this and saying something about muffins and yeeting when you see the word dispersion. So that's cool. Let's talk about the first type of measure of dispersion. That is the mean absolute deviation. Okay, so another way you can remember this, and let's think about what the word deviation means, right? So deviation, like if you're deviating from something, let's say you made a plan and now you're deviating from that plan, that means that you're like splitting off from, you're separating from, you're going apart from. So what this is saying is, what we're trying to find is how far away the pieces of data are from the mean. And then we take an average of that, and that's the mean absolute deviation. There's a formula for it, and we're going to call this, I'll switch pens so this is easier, not A, I meant to write the, sorry. The distance of the data points from the mean on average. Okay, so the formula that we follow here looks like a bunch of gobbledygook, but like if you break it down piece by piece, it really does make sense. So first of all, let's talk about this sigma notation, right? Because we haven't seen that in a fat minute. So sigma notation here is telling me that I'm going to add up all of this stuff, okay, from the point where I is 1 all the way up to the point where I is n, and n is the number of points I have in my data set, okay? And then what this rule tells me to do for this sigma notation is, it says, for every single data point in that set, I need to take the data point, that's what this is the data point, and I need to subtract the mean. So I told you guys we're going to start seeing that mu symbol in more places. So we take each data point and we subtract the mean, and we add all of that up on the numerator, right? That's the numerator of this fraction. And then once we add all that together, we divide it by n, which is the number of data points. So we will put number of points. So let's step through it very carefully one at a time. Okay, so here's your lovely data set. 1, 2, 3, 4, 5, 6 pieces of data. N is 6. What else do we need before we can solve this? What's the other unknown in here that we don't currently have? That would be the mean or the average. That would be mu. So let's solve for mu. And the way we find that is by adding these points up and dividing them by 6. So 85 plus 74 plus 88 plus 80 plus 92 plus 60, that's 6 points, right? Yep. And then you divide that by 6, so your average is 79.83. Let's just leave it as 83. It's actually 833333 repeating. So now I have enough to do this, okay? What, in red, what this formula translates to for this problem is I take the MAD, the mean absolute deviation, is a really big sum divided by n. Well, I know what n is. It's 6. That the denominator was easy, but let's do the top part. What I have to do is I have to find each data point, subtract the mean, and add all of those values together. So let's take 85 minus 79.83, and I get 5.17. So that's my first value, 5.17. Now you might be saying, wait a minute, where does this tell me I have to add stuff? All I see is this subtraction symbol. Okay, remember, this is 2 different operations here, right? This is the rule that you follow to find each thing in the summation. This symbol, the sigma, means summation. So I have to add every result from doing this equation for every value I have inside of my data points, okay? Data set. So let's do the next one. That's 74 minus 79.83. Okay, so I get a negative value for this, but what else is in my formula for mean absolute deviation? Well, you can't even see it anymore because, you know, I kind of drew all over it. But I'm going to grab all those drawings real quick and I'm going to move them out of the way. Okay, so here's all my drawings. We are moving them out of the way. Okay, I'll put them back in a second, but just look at the formula for the mean absolute deviation. those are absolute value bars, okay? So for every one of these data points that I do the data point minus the mean, I just want the absolute value. I don't care about plus and minus. So every one of these is going to be a positive number, okay? So let me put my stuff back. Perfect. Okay, now let's go back here. I said it was negative 5.83. Well, what's the absolute value of that? It's 5.83. Okay, next one. 88 minus 79.83. 8.17. Next one. 80 minus 79.83 is 0.17. And then 92, we have two more, minus 79.83, 12.17. See, I ran out of space. Let's make that longer. And then my last one is 60. Wow, that's like an outlier, probably, right? 60 minus 79.83. The absolute value of that answer is 19.83. Okay, now to find the MAD, all I have to do is add this up and divide by 6. So 5.17 plus 5.83. Be careful when you're keying this in so you don't lose one of the decimal points or a value or something. 0.17, 12.17, 19.83 divided by 6. So all that together is 51.34 divided by 6, which comes out to 8.57. I'm rounding up, okay? This is the mean absolute deviation. Is that a super hard problem? No, as long as you know what to apply in the formula and how to process it. There is a way to do mean absolute deviation using a list, so you would just punch in all of these values, okay? But we don't have, I'm not going to do that on the calculator because I don't think that feature actually is on there. But there is one on the free stat calculator online, which I will show you at the end. Okay, so please, please, please pause your video now and do number 4 while we just did number 3 and you're on that wavelength so you practice how to do it, okay? Give that a shot and then we'll move on to the next thing, which is going to be about the variance and the standard deviation. Okay, hope you had fun with number 4. We're moving on now. We're going to go to page 2 of our notes. We're going to talk about variance and standard deviation and how you can apply that to like make some assumptions about the data. We'll do an example. We'll do a couple more examples. And then I'm going to start giving you the information on how to use the calculator to do this, all right? So the variance is the average squared distance of each value to the mean. Okay, notice this is a little different than mean absolute deviation, okay? So there's no more absolute value here, but you're still going to have positive values because what happens when you square a number? It doesn't matter if it's a negative or a positive, it's going to become a positive value. So the variance is represented by this Greek letter, which is sigma. This is a sigma, and I know you're probably saying, well, wait a minute, isn't this big capital E a sigma also? And the answer is yes. Okay, so you know how in English language, we have capital A and lowercase a. Well, we also have, I can't draw, that looks terrible, let me redo that. We also have capital sigma and lowercase sigma, okay? So keep that in mind too as we go forward because you're going to be seeing this a lot, all right? So the sigma squared, which is the variance, is basically the same type of formula as mean absolute deviation. You're still doing every data point minus the mean, and then instead of finding the absolute deviation of that, the absolute value of that, you're squaring it. And then you add all them together, and then you divide it by n. Okay, let's also talk about something called the standard deviation. You probably have heard of this one before. The standard deviation is the square root of the variance. So it's all the same stuff we're going to do for the variance, except we're going to take the square root. Keep in mind, okay, that the sigma squared is the variance, but the sigma by itself is just the standard deviation. Doesn't that make sense? Because the standard deviation is the square root of the variance, right? Okay, so we do the whole thing for the variance, and then we take the square root of that, and that's how you get the standard deviation. Standard deviation is the most useful measure of dispersion. Muffins. Most useful measure of dispersion. So standard deviation is going to be the one that you look at the most. And why do we care so much about the standard deviation? Because if you have a low standard deviation, that means the values in your data set, lots of writing on these notes today. The values in the data are closer together. And if the standard deviation, the higher the standard deviation goes, the further the values are from each other. Or the further they are apart. Okay, so higher standard deviation would indicate that the data is more spread out, and a smaller standard deviation would indicate that the data is closer together. So on this example on number 5, they want us to find the variance and the standard deviation for each data set. Really, we only have to find the variance, because if we find the variance, we can just take the square root of that and get the standard deviation. So let's plug this in. First, we need to know how many values there are. So I need to know what n is. N is 5. And then we need to also find the average. That would be adding up all those values. 85, 88, 91, 96, and 100, and dividing that by 5, and that gives me 92. So the variance, or the sigma, little sigma, I should say, is going to be found by doing a whole bunch of adding and dividing that by n, which is 5. So we need to take the 85 minus 92 and square it. I'll go ahead and write the whole thing out so you can see how it's all done. So you take the 85 minus 92 and you square it. You add that to 88 minus 92 squared. You take 91 minus 92 squared. See, I'm running out of room again. 96 minus 92 squared plus 100 minus 92 squared. Once you find all of those values, then switch this over to 2. Let's make my line a little longer. Beautiful. Once you get all this, then you divide them by 5, okay? Now, I'll use my super awesome math brain and just simplify this. So variance, 85 minus 92, the difference there is it's going to be -7. And then we have a difference here of 4, -4 squared, -1 squared, 4 squared, and then, didn't mean to scroll that. And then we have 8 squared, all divided by 5. One more time, let's simplify this. This is 49 plus 16 plus 1 plus 16 plus 64, all divided by 5. And then if we add that together, 16, 1, 16, 64. I'm running out of space, whatever. It's 146 divided by 5, which is 29.2. So the variance is 29.2. How do we find standard deviation? We take the square root of the variance squared, which is 5.4. We'll keep that rounded down. 5.40. 5.40. That's enough. That's fine. We don't need to do any more than that. Okay. Number 6, I want you to do. Now, I will caution you. Do you notice how there are calculator steps here on the left? This is for a TI-83, a TI-84, a TI-84 Plus, a TI-84 Color Edition, a TI-89. Basically, it should be the same in all these calculators. If for some reason you have one of those and it's not working for you for whatever reason, come to office hours, we'll troubleshoot it together. I'm going to show you both ways. I'm going to show you the calculator way on the TIs, and then I'm going to go and flip over to a free website that you can use. And remember what I told you in the beginning about the free website, okay? You want to start thinking about investing in a calculator like this if you don't have one already, okay? Because you will be able to use calculators on exams most of the time, but you will not be able to go access some website on the internet. So let's go ahead and we're going to enter this data into a list in our calculator. We're going to hit the stat button. That's what this button is right here, stat. Oh, can you see that? Let's see. Yeah, you can see that. Okay, we're going to hit the stat key. That brings us up to our stat menu. We're already in the edit menu under stat, and that's what we want. I think maybe it would be better if I zoomed into the screen a little bit. Probably, yeah. Okay, so we're in the list, and I'm going to roll this down a little so we can see the data still. This is very complicated. Let me tell you something. I'm glad I'm a teacher and not a videographer, okay? Okay, so here we go. So we're in the edit menu. We're going to hit enter so we can go and edit this. There's already some data here which I want to clear out. I'm just hitting the delete key to delete these old data points. I don't need them anymore. It's from something else. Let's put these points in. So 3 is my first data, 4 is my second, 7, 8, 11, 12, 12 again, 15, 19. That's my list, okay? Now I'm going to hit stat again. I'm going to use my arrow key to go over to calc, the calculation menu. These are my stat calculations, my statistics calculations. I can do a whole lot of things with this set of data, but all I really care about right now is one variable statistics. So hit enter, and it's asking me what list I want to use in order to calculate this data. And I just entered all that into list 1. Let's say, for example, that I needed to change that and I put it all in list 2 or something. I would hit the second key and then the stat key, and that would bring up all of my possible lists. Let's say I'm going to put list 4. Now it's going to do the data for list 4. But I put my data in list 1, so let's fix that. I'm going to do second stat and then go back to list 1. I'm going to hit enter, enter, calculate, and here's all these lovely statistics, okay? So what you need to do is you need to be able to actually look at this list and determine the things that you need from it. The very first thing in the list is the mean, that's X bar, okay? Then we have a couple other things. The sum of all the values, this is a summation, this is a sigma, and X stands for a data point, so the sum of all the values is 91. The sum of all the values squared is 1133. There's applications where you might need to know that information. That's why they give it to you. They give you a whole bunch more information. What we're looking for is we are looking for the variance. Okay, and the variance was given to us. It is actually not the variance, it's the standard deviation, okay? So they gave us the little lowercase sigma. The standard deviation right here of this of these data points is 4.86. So in my answers, I'm not even sure if this will let me write. Maybe it will. I'm going to put 4, yeah, it will. 4.8, let's round it, it's 7. Now, you're probably wondering now, well, didn't we go backwards here? Weren't we supposed to do the variance first? Well, variance is not, like I said, standard deviation is the best measure of dispersion. And so this calculator doesn't even really tell me what the variance is, but I can find it really easily by just squaring my answer. So 4.87, and if we hit the squared key, gives me 23.7169. You can just put like 717 and round it. That's fine. But that's the gist. That's how you find these values using the calculator. Now, let's flip gears and let's go and do this actually on, let's zoom out a little here. There we go. You can see I wrote my answer. Let's change gears and let's bring this over to a stats website I want you guys to try out. And the stats website that I want you to use is called hackmath.net. And once you go there, you're going to click on calculators. And if you scroll down, there's going to be a stats one somewhere right here, statistics. So what this is asking you for is in this box, you want to put in your list, right? So the list we're going to put in, we're going to separate by commas. So 3, 4, 7, 8, 11, whoops, I can't type, 11, 12, 12, 15, 19, and then we're going to hit the calculate. It refreshes, and then I scroll down here. Here's my list of information, and then it tells me all of this info. This is actually more information than the calculator gives me, okay? First we have the, let's see, the mean deviation, okay? So the mean deviation is the average. This is the mean absolute deviation. So if that's what you're looking for, it's this field right here. It tells us the min and max. It tells us the variance, which is sigma squared. And then it tells us the standard deviation, which is sigma. And so this calculator will do that for you, and feel free to use that for this and also for your delta math. And that's it for this lesson. So remember, the orange squares are the ones that are classwork for you that I need you guys to fill in. And then you also will have a quick delta math assignment that takes you through calculating some of these values of statistics. All right, guys, thank you so much for tuning in, and I will see you next time. Bye-bye.